Yes, please. A very good evening. And a very good evening to online students too. Shallow men believe in luck, strong men believe in cause and effect. This is for those who talk a lot in the classes. Remember, deep rivers run quiet. Those who become toppers, they were the ones who remain silent in the class. No? We got to know about those people only after the selection. And those who try to be different in the classroom, they really don't turn up anywhere, right? So try to be different by your results in the examination. If you do not climb the mountain, you cannot view the plain. Strivers achieve what dreamers believe. All art is but imitation of nature. Now, please get connected to the lecture. I believe that we left at the diagram of troposphere. Am I right? Now, see, I'll repeat the diagram on the board. You already have that with you. So just be on the board for 2 minutes. I took a line like this last time to represent the Earth's surface of entire northern hemisphere. And one end was the equator here. The other end was North Pole. The first zone of the atmosphere called troposphere is the zone where, in general, mind the words carefully, in general, with increase in height, we have a decrease of temperature. And for the reasons we'll understand today, that this decrease of temperature is seen up to higher elevations over the lower latitudes of the world. But as we go towards the poles in both the hemisphere, the elevation up to which this decrease is seen keeps decreasing. By the time I reach to the poles, it is much lower. In particular, over the equator, this height is 16 to 18 kilometers. And over the poles, North or South Pole, it may be only 8 to 10 kilometers. So it means a tropopause, which is the upper limit of troposphere, is not a horizontal zone like this. It is inclined, lower over the poles and higher over the lower latitudes. So this line represents tropopause. Now we left it here only, right? So there are some basic questions which we would have immediately when we look at this structure. The first question is where the height of tropopause varies the way it is shown here. Then second question would be that why this zone is named as troposphere. Then more interesting point would be in today's lecture that in the next 45 minutes or so, say within 1 hour's time, you'll understand something very interesting. And that is that when a geographer uses the term atmosphere, he or she means only troposphere. It means unless until stated otherwise. Whenever I'll use the term atmosphere in my geography class, I would only mean troposphere. It means when I teach you about some other part of the atmosphere, I'll make a specific mention of it. So what is that reason that troposphere is the real atmosphere for the student of geography? And this was a question, the main exam this year for 15 marks, that what is so special about this? What is the basic reason, right? So we'll understand that today in this lecture. And then we'll also see in this discussion today that which is the zone which provides the ideal flying conditions for aircrafts. Means when you travel by air, most of your journey time is spent in which part of the atmosphere? That also we'll study today, right? Now, but to answer all these questions, we need to learn some basics of the school science once again, and some basics about the movement of air in the atmosphere. So now we leave this diagram and we'll visit it after 45 minutes or so, okay? So let's collect all what is required to answer these basic questions and proceed further in the subject. So first section would be, I'll talk about very, very simple statements about the movement of air. If you wish, you can write basic concepts. Means I don't have any other title to suggest, so you can write basic concepts, okay? And some very simple observations will come, but very important ones. And please don't write anything till I make you write. Just be a listener on the board with me. Now see, books will write, moving air is called wind. But to make it little interesting, I say in my classes, air in a hurry is called as wind. So tell me, how many of you will feel that very often air is in a hurry? Have you felt it? Now, when you stand on the road outside, how many times it happens in a day that air comes from behind and without even saying, excuse me, it overtakes you? Have you seen air is trying to overtake everyone? Every human being, every other animal, every automobile, every building. Air is in this process of overtaking only all the time. So this air which is generally in a hurry is what I call as wind. Now the question next arises is why air is in a hurry all the time? The reason is that our atmosphere exerts unequal, non-uniform pressure on the Earth's surface. It means the atmospheric pressure is not uniform on the Earth's surface. Somewhere you have high pressure and somewhere you have low pressure. What does high pressure mean? High pressure means more air acting over you. Low pressure means less air acting over you. So what Mother Nature is doing? Mother Nature, every moment outside, is trying to balance this unevenness of pressure by sending air from higher pressure to lower pressure. So this horizontal movement of air, mind it now. So this horizontal movement of air from higher to lower pressure is technically what we call as wind. Now the next question will raise is that why do we have differential atmospheric pressure? Why pressure varies from one place to the earth, one place of the earth to another? Then the primary reason for is that our heating of the earth's surface by the sun, by the insolation, is not uniform. So basic reason for pressure differences is that there is a differential heating of the earth's surface. Now one area is heated more than the other. You know, lower latitudes are heated more than the higher latitudes. So the area where the heat is more, the air is warmer, and warmer air is lighter, and lighter air would rise. So wherever the air rises, you'll have less pressure over you. And in comparison, where the conditions are colder, the air is denser, it sinks over you. So wherever the air sinks over you, you have higher pressure. So it means the simple relationship of temperature or heating is that higher temperature would correlate with lower pressure. Lower temperature would relate to higher pressure. But When you go outside in the nature as a science student, you'll find the pressure distribution is not so simple that high temperature have low pressure and low temperature areas have high pressure. The nature outside is having something more complex than this. Now, why the pressure distribution of the atmosphere is more complex? Because in the coming classes, we'll understand that, that besides differential heating of the Earth's surface, there is some role of the Earth's rotation also in the causation of pressure of the atmosphere. How does Earth rotation play a role in deciding the atmospheric pressure? That would take little time to be understood, because I'll just give you a hint. You have done it in school science or higher level physics, that we will see in the coming days, not today, perhaps in the next lecture, we'll see that rotation causes a force called Coriolis force. Remember, you have done it in school? Very good. Which batch is this? I'm really impressed. J1 batch, no? So next, no, it's J1. So next time I'll come better prepared for this class. That you are already informed that. I thought I only knew about this force. Okay, very good. So Earth's rotation causes something called as Coriolis effect or Coriolis force. And Coriolis force would affect the movement of air. If the movement of air is affected by Coriolis force, it would affect the pressure distribution also. So at this moment in today's lecture, we'll just know that the pressure distribution of the atmosphere is the combined effect of differential heating of the Earth's surface and Earth's rotation. Details will come when we'll talk about Coriolis effect, right? Now, but since the primary reason, remember, what is the basic reason for it to move? Pressure differences. And primary reason for pressure differences? Heating by this. Remember, differential heating is the base reason. Rotation is complicating the matter. But basic reason for differential pressure is differential heating. Now, one, heating is differential because the two areas have different locations. One lower latitudes, the other second higher latitudes. The two areas may have the same location, but one area may be land, the other may be water. Because specific heat of land and water are not same. Land gets heated faster, loses that heat faster, and water takes more time to get heated up and retains that heat longer. So one location is same, but surface is not same, right? Sometimes location is same. Both the areas are land areas only, but one may be grassland, the other may be forest or maybe desert. So we'll see that even if the two areas are land, but the surface is different, still the heating may be different, even if the amount of heat of the sun is same. So in the coming classes, we'll be also studying a property called albedo. What is albedo? The word albedo comes from the Latin word albus. Albus means white, and white stands for reflectivity. So if there is a particular surface, out of the total incident energy, how much of it gets reflected back is called albedo of the surface. So it means albedo also becomes a determinant in heating of the particular surface. Some surfaces would absorb more and reflect less, and some would reflect more and absorb less. Let's have a few examples. First example from the class itself. Some students appear to me very bright today in this class. Most of you are dull. Now, what does that mean? Now you'll say he has not taken any test and still making such a judgment. Who are the bright students today in my class? Those who are wearing bright colors. What are bright colors of life? As per physics, the bright colors are those which have higher albedos, which reflect more, they appear bright, and those colors which are absorbing more, they are dull in appearance. So this is one example of albedo in the class. Second, think of snow and ice. Now, some of you might know that when you go for skiing to high mountains, the first thing you need for your protection is glasses, sunglasses, because snow and ice have very high albedo. 70 to 90% of the incident energy may get reflected from freshly fallen snow, as much as 90%. So imagine if this is freshly fallen snow surface, 90% of energy gets reflected and a strong glare can damage your eyes on a summer day. So foremost important thing for skiing is that you must have very good protection for your eyes because albedo of snow and ice is very high, as much as 90%. And this is what will make it important for global warming and climate change. Why every scientist talks about the melting of snow and ice in this area of the world in the higher latitudes? Because this area is having more and more of melting of snow and ice because of global warming. So as more and more of this snow and ice cover is getting removed, the earth is going to get more and more of heat being absorbed. It means more the snow melts here, more would be the global warming as such. It means the melting of snow and ice because of the global warming is going to result in further amplification of it. And that is why this area of the world is going to act as a barometer of climate change. That here the impact of global warming would be larger as well as earlier than the other areas of the world. So this is all related to albedo of snow and ice being very large. Another example for, remember this will come later in detail, but today just broadly. Another example is, imagine you are in a city of Delhi in the month of May, and you have gone outside somewhere and you have lost your sleepers. Can I say on the summer day, when you have been out and you have lost your sleepers, you will jump back to your room. Means you can't say that I'll walk back to room. You'll be jumping back because the bituminous material which is there on the surface on the urban roads, that black material has how much of albedo? Just 10%. It's almost opposite of freshly fallen snow, that the bituminous material on the road will absorb as much as 90% of the incident heat of the sun on summer day, and only 10% is reflected back. So this is another good example of albedo. Then another important example of albedo would be in our classes later, clouds. On a summer day when you are being tortured by the heat, if a cloud comes over you, you get an instantaneous relief as if you have entered a building. It means most of the thick clouds would have very high albedo. And generally we say clouds may have albedo between 50 to 70%. Now these are just preliminary examples, but I hope you understand albedo would become an important determinant of heating by the sun, right? So it means there are various ways to understand that we have differential heating of the earth surface. So since the rotation of the earth comes little late, to complicate the matter, so my notes today will say for the initial discussion that the ultimate driving force of wind is solar radiation. Sun, very good, someone said sun, solar radiation. No? That heat of the sun is the basic reason for air to move, right? Now, having said this, let's make one more rule. When air moves horizontally, we call it as wind. Now, you have two directions of the wind, the direction of its origin and the direction of its destination. Our ancestors named the wind always from the direction of origin. So we'll follow the same rule. For example, if this is India, during summer season, we have southwest monsoon. Why do we call it a southwest monsoon? Because the winds come from southwest. During winter, South Asia would have northeast monsoon. So it means the rule is wind is named as per its direction of origin. Now you may have a question that why do we name the wind as per our direction of origin? The reason is simple, perhaps. When I know from where the wind is coming, I can make some guess, some idea about the nature of that wind. For example, when someone tells me that during summer, India gets covered with the winds from southwest direction, it means I understand it is a moisture-laden system of air. It will bring a lot of rain to India. When someone tells me in winter, the winds are coming from northeast, I understand they are coming from land, and that to cold area of the world, Central Asian region. So it means it won't have much moisture. So our ancestors did a good job by naming the wind as per the direction of origin. One more point before we write these simple observations. Horizontal movement of air is called as wind. When the air moves vertically up or down, we'll call it as current. There are ascending currents and there are descending currents. Okay. So let's write all these observations, and whatever I don't make you write, It means that will come better in some other lecture. Okay. So please write simple observation. First observations under basic concepts, please write. Air in a hurry is called wind. Or those who don't like this language, please write moving air is called wind. Okay. Air in a hurry or moving air, you can write, is called wind. Then write, in particular, next point, write simple bullets, short bullets. Number one, second point, in particular, horizontal movement of air is called wind. In particular, horizontal movement of air is called wind. Then write, next point, air is generally in a hurry because of pressure differences. Or simply write, air is in a hurry because of pressure differences. Air is in a hurry because of pressure differences. When I say pressure, means atmospheric pressure. Air is in a hurry because of pressure differences. Then write, air moves from higher pressure to lower pressure. This is being said in the context of wind only, right? Air moves from higher to lower pressure. That is, wind is nature's attempt, further writing the same. Air moves from higher to lower pressure. That is, wind is nature's attempt to balance. Wind is nature's attempt to balance the uneven distribution of air pressure. Wind is nature's attempt to balance the uneven distribution of air pressure. Next point, atmospheric pressure differences are primarily caused by differential heating of the earth's surface. Atmospheric pressure differences are primarily caused by differential heating of the earth's surface. The right next point. Therefore, the ultimate driving force of wind. Therefore, the ultimate driving force of wind is solar radiation. Therefore, the ultimate driving force of wind is solar radiation. Next point. Atmospheric pressure differences are further complicated by Earth's rotation. Now, when you write Earth's rotation, you can write / Coriolis effect. This we'll study in the coming days. Coriolis force or effect. Coriolis was the name of a French mathematician. So Coriolis effect of force. The right next point. As per a convention, wind is always named according to its direction of origin. I repeat, as per a convention, wind is always named according to its direction of origin. Next point. The vertical movement of it is called current. The vertical movement of air is called current. Would I have it right? There are ascending and descending currents. the ascending and descending currents. Now on the margin, please write this word, it will come later. So just write on the margin today, please write albedo. Within bracket, origin from Latin word albus, which means white. The word albedo comes from the Latin word albus, which means white. And albedo refers to reflectivity of a surface. And albedo refers to reflectivity of a surface. Now you can write one or two examples. Yes, please. Please write. Snow and ice surfaces. Albedos against that you write. Albedos range between 70 to 90%. Freshly fallen snow may have 90% of albedo. Thick clouds may have albedos between 50 to 70%. Now, let me add just interesting, just to see here, every surface of the earth has different albedo. And if, means this will come later also, if someone asks me that how much is the average albedo of the earth as a planet, then it is around 32%. Some books will give 30 or 30 to 35%. It means about 1/3 of the incident energy is being reflected back. And that is the reason that everyone who has gone to space and has seen the earth from outside has always said that earth looks very beautiful from outside, no? Remember Rakesh Sharma, when Mrs. Gandhi asked, how does India look from there? So he used that, he said, Sare jahan se acha. So in fact, he just made it political also, no? But presence of mind is there. So, but otherwise, earth looks beautiful as a very bright planet from outside because the albedo is so good. Now tell me, in comparison to the earth, moon's albedo would be less or more or same? It would be much less because moon doesn't have atmosphere. Moon is more like a dead body, right? It doesn't have anything of its own. So moon's albedo is almost 1/4 of the earth's albedo. It is only 7 to 8%. So moon is basically getting or appear bright because of sun's energy being reflected back, right? Since it doesn't have atmosphere, remember, atmosphere would give you clouds and all that. So reflectivity will keep increasing. So earth's albedo is 4 times the moon's albedo, and earth is about 4 times the size of the moon. So both ways it is having an advantage. So that is why it appears much brighter from outside. Fine. More examples will come later. So you understand what is the importance of albedo. Albedo is one of the determinants for heating of a surface. No? You can write on the margin. Albedo is an important determinant for heating of a surface. In the previous lecture, I have given you the term convection and conduction, right? So now let's go for another important concept of school science, which would be very essential for taking the classes further. Just write this title. Adiabatic change in temperature. And please don't write, follow me on the board. See here. Today I'll introduce one concept in atmospheric science, which will be of use in many classes later. If I show by this line some particular area of the earth surface, and then I make this vertical atmosphere over it. Now I'll introduce a concept called column of air. Means before I come to this concept, adiabatic change in temperature, let us develop a concept for all classes of atmospheric science. It is called column of air. Now see, background is that when air becomes stationary over a particular uniform surface for a long duration of time, there develops a relationship between the air and the earth surface. Remember, as in human beings, to have relationships, you need to be together for some time. Yes, no? Staying in Delhi, understood. But remember first rule, first lecture rule. Some are breaking the rule, I understand, on the road I have seen. Okay, fine, good. At least you remember the rule. So see, when air becomes stationary over a particular uniform surface, for example, if air becomes stationary over desert like Sahara, then over a period of time, there develops a relationship between the air and the surface. And this relationship is a two-way relationship. The air would influence the surface and surface would influence the air. And as a result of it, what happens is the vertical atmosphere over a particular area develops a particular identity of its own, which is different from the air which is over the adjoining area. So imagine this line represents Sahara Desert and this area is nearby Atlantic Ocean. So when a child will understand, the air which has remained over Sahara Desert would have temperature conditions and moisture conditions which are really very different from the air which is stationary over the nearby Atlantic Ocean. So this is how we have columns of air being formed. So what is column of air? The vertical atmosphere over a particular area with a particular identity of its own. So you will see that most of the atmospheric science is understood by comparison of one column of air with adjoining column of air. Means we'll see in the coming days that if I wish to investigate what would happen in this column, then I first need to understand its position vis-a-vis adjoining column. Then I'll be able to understand whether the air of this column is going to rise or sink. And then thereafter we'll have additional knowledge and then we'll be able to figure out what is all expected in the given column. So today I make it very simple. I say, what is column of air? The vertical atmosphere over a particular area having a particular identity of its own. Identity means in terms of temperature, moisture conditions, etc. So please write this concept on the margin. Your main topic is adiabatic change in temperature. So write on the margin, column of air refers to the vertical atmosphere. The column of air refers to the vertical atmosphere over a particular area of the earth surface. Over a particular area of the earth surface. And having a particular identity of its own. And having a particular identity of its own. I repeat, column of air refers to the vertical atmosphere over a particular area of the earth surface and having a particular identity of its own. Now, let us use this concept to understand what is adiabatic change of temperature. Now, let's have the background point. See here, generally when we think of change in temperature of a body, we think in terms of transfer of heat. Means, you know, when we touch a hot body, then the heat would travel from the hotter body to the colder body. And as a result of this heat transfer, the temperature of both the bodies may change. Clear? Now, it means we have seen more often the changes in temperatures of bodies which are because of actual transfer of heat. Is okay? But we will see that there are certain changes in temperatures of bodies which are not because of the heat transfer, They are more because of some other reason. So when heat transfer is not the reason, but there is some other reason for change in temperature of body, such changes are called adiabatic change in temperature. So I repeat, change in temperature of a body which is without heat transfer is called adiabatic change. Write the sentence, then we'll go further. So define this, please. Write adiabatic change in temperature of a body. Adiabatic change in temperature of a body. Adiabatic change in temperature of body is the one which is without heat transfer. Is one which is without heat transfer. Is the one which is without heat transfer. Then write next sentence and that you will understand. Please write. In atmospheric science, adiabatic changes of temperature play significant role. In atmospheric science, adiabatic changes in temperature play significant role. In atmospheric science, adiabatic changes in temperature play significant role. Means in atmosphere, in air, such changes are very important. Okay. Now please be on the board. Let us understand what is adiabatic change. Because when you say it is a change without heat transfer, then certainly the immediate question would be, then what is the reason for change? So let's understand. And in the next 10 minutes time, I'm going to discuss very, very simple thing. But the two results which you will get, they would be the golden rules of this subject of atmospheric science. Means whatever I teach you next 10 minutes would be needed to understand monsoons, cyclones, everything relating to atmospheric science. They are so important, but all simple from school days. So please see here. Let us suppose let us suppose the air in the given column of air near the earth surface is warmer than the air near the earth surface in the adjoining column. So this air being warmer and being lighter would rise. So this air rises. Is okay? So warmer air being lighter would rise. Now as this air starts rising, I notice that this air is getting cooled. So I notice that rising air of my given column is column under investigation, is getting cooled. So as a science student, I wanted to know the reason for its cooling. So since I knew from school days, cooling happens because of transfer of heat. So I thought this rising air is transferring its heat to the adjoining columns of air. That may be the reason for its cooling. So as a student of science, I measured or I checked first that is this rising air transferring its heat to the adjoining columns? I found yes, it is transferring. So I found this rising air is transferring its heat to the adjoining column. But when I measured the amount of this transfer of heat to the adjoining column, I found this transfer is so negligible that after today's lecture, I will never ever mention it again. What does it mean? It means rising air does not transfer any significant amount of heat. It is so negligible that it is not to be discussed again in the class. Okay. So it means, what is the understanding? This rising air, since I've already seen it is getting cooled, and I have now found quantitatively this transfer of heat is very negligible, because air is not a good conductor. Remember you wrote last time. So this transfer is so less that this cannot be the reason for cooling. It means one thing is clear, that rising air cools. Yes, please. It cools adiabatically, because what is the definition? Adiabatic cooling means cooling without heat transfer. So one thing is clear, scientists have done it. They have measured the amount of heat transfer and they have understood that this is not the reason for cooling. So it means the cooling is adiabatic. Now the student will ask me that what is the reason for cooling if not the transfer of heat? Answer is the warmer air being lighter rises. As it rises, it is coming under lower and lower, less and less pressure. Remember, when the air is at the ground level, it is under the entire column's pressure. But when this air comes under, when comes it here, the pressure is less. When it comes here, the pressure is further reduced. So as warm air is rising, it is coming under increasingly lower and lower pressure. And when the air comes under less and less pressure, this air expands. And you know, expansion utilizes heat. And that expansion becomes the reason for its cooling. And therefore, this is what cooling? Adiabatic cooling. So it means I sum up I repeat the whole point. Warmer air is lighter, therefore it rises. As it rises, it gets adiabatically cooled. You ask me reason, I say because of expansion. Someone says, why does air would expand on rise? Because it is coming under less and less pressure. This is the first golden rule of atmospheric science, and you will be surprised later that this is how Mother Nature will make clouds. Why do we have clouds away from the Earth's surface? Because for clouds formation, you'll understand later that nature would need cooling. And cooling would be mostly done by upliftment of it. Okay. So that is the reason that clouds, majority of the clouds of the world are away from the Earth's surface. Now you'll say, sir, which cloud is closer to the Earth's surface? Then I'll say, think of fog, think of mist, haze, etc. This is also condensation, later you'll understand, right? But here there is some special process. Most of the cooling is by upliftment of air. So write this golden rule, will work wonders in the classes. Please write, warmer air is lighter. Warmer air is lighter, therefore it rises. Warmer air is lighter, therefore it rises. Full stop. Next sentence. As air rises, it gets adiabatically cooled. Sorry. It gets adiabatically cooled. Because of, yes, please, what is the reason? Because of expansion. It gets adiabatically cooled because of expansion. Within bracket, if you wish, you can write the reason. Please write air on rise. Please write within bracket air on rise, comma, expands as it comes under, increasingly lower and lower pressure. As it comes under increasingly lower and lower pressure, close the bracket. As it comes under increasingly lower and lower pressure. Now there's a student Shivani asking that online, that sir, the size of one air column could be as large as Sahara Desert as a whole. Yes, if not the whole Sahara Desert, you can say major part of it. So remember, when a geographer uses the term large, huge, it is really huge. Yes or no? When I say mass of air, air mass, I mean a mass of air which is covering horizontally thousands of square kilometer area. And vertically, it might be having 5-6 kilometers extent. So basically, in nature, we are dealing with big things, and they're really big as such. So this is your first rule. Now, second rule is just the opposite of it. If you are okay with the first one, second won't be a difficulty. See here. Let us suppose this air at height h is found to be colder than the surrounding air at the same height. Remember the rule of the game? I leave this for a minute. I teach you one very important rule for prelims next year and for life in general. Remember, comparison to be logical. Remember, in every subject we'll have to compare sometimes, no? Even history would demand comparison. Geography may demand comparison, polity, or your life also. So one rule is that for comparison to be logical, the comparison must be amongst the comparables in life. Think of this. Many a times your question's answer will go wrong in prelims because you required comparison of something and you went for a comparison which was not among the comparables. So do remember, comparison to be logical must be amongst comparables. In statistics, you have read a statement, oranges must be compared with oranges, not with apples. And you people follow this rule in your life, but in exam, you don't follow this rule. Prelims, 1 or 2 questions go wrong for this reason, that you went for illogical comparison. But in life, you follow it. For example, think of graduation days when you are asking for the bike from your father or anything else. And in one particular heated arguments, your father came to say that look at Mr. Sharma's son in the locality. He goes to the same college as you go. He goes by metro. Why can't you go by metro? Then you had to tell your father that day, don't compare me ever with that Sharma son. Did you say that or not? Or Gupta son? Anyone? Now, why did you say so? Because you told your father that Mr. Sharma son only goes to the college. You misunderstand. You never let me complete the sentence and you always make a judgment. This is not good. See what I was saying. Since I'm thinking of civil service examination, so besides my regular classes, I go for coaching classes also. Then I go to a library. Then I have to meet some senior sometime for some guidance. So therefore, I need a bike. So you understood so clearly that comparison must be among comparables. This is what you have to follow. I tell you, you will avoid 1 or 2 mistakes in your prelims exam. And your answers in the interview would be much better if you follow this. So do follow this rule in science classes also. That is why you would notice when I compared in the previous case, air near the earth surface, I compared it with the air near the earth surface in the adjoining column. Now I'm saying I find the air in this column at height h1 is colder than the air at the same height in the adjoining column. What would happen to this air? This air would sink. Now when air sinks, it will get adiabatically warmed. Why? Because this air is under compression, right? So air, when it sinks, it is under compression, and that becomes the reason for its heating. So please write this opposite rule, and you will find it later in the classes. Such air will never give you clouds. So those areas of the world where we'll see air in general sinks all the time, those are the areas with clear skies, dry conditions. This might become later as one of the reasons for deserts of the world. I'm not saying only reason. One of the reasons for desert formation. There would be some deserts of the world near 30 degrees belt, 30 degrees subtropical areas. There the desert may form because of the fact that in those areas, for some reason, you'll understand, air regularly sinks because this is going away from the cooling process. It's opposite. So clouds will not form. So write this rule today. Please write, colder air is denser, therefore it sinks. Colder air is denser, therefore it sinks. Full stop. Right, next sentence. As it sinks, it gets adiabatically warmed. It gets adiabatically warmed. Okay. Now see, we'll stop in this discussion here only, but somewhere after the chapter of clouds, when we'll be able to appreciate the process of condensation much better, we'll be able to talk about the release of latent heat, etc. Then you'll understand how much is the rate also. Because someone may have a question immediately here, but none of you asked me. It's good that you didn't ask me. That, as I said, warm air rises, it gets cooled. A good student might have asked me, sir, what is the rate of this cooling? At what rate does it cool? And when the air sinks, at what rate it does get adiabatically warmed? These would be understood numerically in some other lecture after the chapter of cloud formation. Okay. But today I'll discuss something different related to temperature decline only. So we close this discussion. So you have 2 rules which are like golden rules of this subject. So once again, I repeat, warmer air being lighter would rise. And as it rises, it would adiabatically cool because of expansion. Why does it expand? Because it is under less and less pressure with the rise. Opposite is colder air, denser air is sinking and it gets adequately warmed. Coming days will understand the rate of cooling as well as rate of heating. Now, let's go for this in a more broader way now. With increase in height in the atmosphere, we expect and generally get decline of temperature. You are told in the previous class that majority of the heating of the atmosphere is by Earth's out radiation. Yes or no? That most of the heating, main part of heating is by Earth's out radiation. So it means the real source of heat of the air is not the sun, direct sun, it is the Earth's out radiation. So higher I go, more I go away from the real source of heat. So with increasing height, I expect and I generally get a decline of temperature. Now, whenever we talk about this decline of temperature, we will use the word from English language lapse. Lapse, you know, is decline. And since in science we are interested in the quantification, means in the rate of decline, so we'll use the word lapse rate. Okay. So now in the next 10 minutes, we'll understand two rates of decline, two lapse rates, which we use in our atmospheric science. Let's see it in a practical way. Let us say a student raises a question today in my class that, sir, at this Karol Bagh place, means a particular place, Karol Bagh, at this time of the year, what is the rate of decline of temperature with height? So think of a student, a very smart student in the class raises a very specific question to me that, sir, in Karol Bagh, means at a particular place, at this particular time of the year, what is the rate of decline of temperature with height in the atmosphere? The only good answer I can give is, you wait, I go and check it up. Because I know as a science student, the rate of decline of temperature with increase in height would depend on local weather conditions. Yes or no? Means what is the rate of decline of temperature in the atmosphere outside? It depends on the changing conditions of atmosphere outside. And you know, weather by definition keeps changing. So to give you a good answer, the best, because the situation for me is that I keep your class here and I go up and check it for you, because weather conditions decide what is the rate of decline of temperature with increased height. So let's suppose for a moment, our institute has provided me the means to do this exercise. So you wait for me for half an hour. Let's suppose I went up and I discovered that over Karol Bagh, at this time of the year, at this time of the day, I discovered a decline of X degrees centigrade per kilometer rise in the atmosphere. So you asked me about this place and this time, and I knew that it depends on the weather condition outside. So I went up and checked it. And after half an hour, I came with the observation that in Karol Bagh at this time, there's a decline of X degrees centigrade per kilometer. Now this rate, which is the actual rate of decline for a particular place and a particular time, is what we call in science as the environmental lapse rate. Please don't write anything, just follow me on the board. In short, we'll call it in our class as ELR. Now, why do we use the prefix environmental for it? Because it is in a given situation. At a given place, at a given time, the actual rate of decline of temperature with increase in height is called as ELR. But you know, if I change the place, let's suppose at the same time, when I have discovered X degrees centigrade in Delhi at Karol Bagh, let us say similar class is going on in Srinagar, and if some teacher goes there up in the atmosphere at the same time as my journey was there up, so what do you expect? Would the decline in Srinagar at the same time be same or different? Certainly different. Common sense tells me the weather conditions there in Srinagar are different. So it means if I change the place, it is bound to change. Or second possibility, that let's say I'm doing the same lecture tomorrow morning with some GS batch, and there also I need to check. So place is same, but I do it tomorrow morning before sunrise. Tell me by common sense, will the rate be same or different? Different. It means one thing is clear, that ELR would vary a lot. It means ELR would vary spatially, means from place to place, and it would also vary in temporal ways. So scientists of the world have found that there are lots of spatial and temporal variations in the value of ELR, because ELR by definition depends on the given weather conditions, and weather conditions would vary from place to place or at a place from time to time. So ELR is the real rate, actual rate. Now let's think of another situation. As I was teaching this topic, someone asked me again the same question, that sir, at Karol Bagh at this time, what is the rate of decline? I said, you wait and I go. But the student was very smart. He said, I know your trick, sir, you waste time of the class. Means half an hour you will take going up and half an hour coming back, and after 1 hour you will give us the report. So he or she says, sir, don't go anywhere. You just give me an idea, some sort of average value. What means someone says, I'm happy with this answer only if you tell me that what is the expected rate of decline of temperature with increase in. So if someone doesn't want the real value, then scientists of the world have done a favor to us. Scientists who have studied the ELRs of different places of the world at different times of the year, year after year. They have done it studies for decades, no? So those who have done these studies of ELRs for different places of the world, for different times of the year after year, they have given us an average concept of ELR. And the average concept in science is called as normal lapse rate. In short, we'll call it as NLR. Now you'll say, sir, what is the value of this average? So scientists say, based on the real observations of ELR, they say on an average, you can expect a decline of about 6.4 degrees centigrade. Some book may say 6.5. So decline of 6.4 degrees centigrade with per kilometer rise in the atmosphere. So this is what this is. Average means it's an estimation. In reality, at a given place, when you go up, the real rate may be less than this or close to this or more than this. This is something like you told your father, I expect this score. Yes or no? Or you'd say, bet me a bike, this time I'll get you 95% score. And father says, I know your mark sheets of the previous years. Yes or no? He has this idea of average. No? So you are trying to fool him by saying, this year I'll do something. But father says, I have 10 years records with me, where the average is 6.4. So it means we have learned two rates today. Real rate is ELR, and the average concept is normal lapse rate. So please write ELR first. Environmental lapse rate. In short, within bracket, ELR. Please write. It is the actual rate of decline of temperature. ELR. You are writing for ELR. It is the actual rate of decline of temperature with increase in height in the atmosphere. With increase in height in the atmosphere at a particular place and time, at a particular place and time, under local weather conditions. Under local weather conditions. Then write further in the same point. It is seen to have, or you can write it is found to have, it is seen to have lots of, spatial and temporal variations. Spatial and temporal variations. The sentence you've written before this, what is the most important word in that? Actual, right? So underline the word actual. You wrote it is the actual rate of decline, no? The real value. Now you write next concept, normal lapse rate, NLR. Now there's a student asking that can we call such movement of air parcel as currents, ascending and descending currents? Yes, these movements only are ascending and descending currents, what I said earlier as vertical movement of air. Now you write NLR, normal lapse rate. Please write NLR is the average concept of ELR. NLR is the average concept of ELR. And it is generally estimated, to be decline of, be a decline of about, yes please, how much? About 6.4 or 5 degrees centigrade per kilometer rise in the atmosphere. Okay. So we have learned two rates today, ELR and NLR. What is ELR? Actual, and NLR is average. Right. Now let's develop a new concept in addition. Please now you write temperature inversion. Just write the title and give me 10 minutes on the board. See here. With increase in height in the atmosphere, we expect and generally get a decline of temperature. But remember, whenever I said this, we kept saying in general there is a decline, right? So, yes, generally we get a decline of temperature. But there are some special situations of nature which we are going to discuss in more detail in the coming classes, but today concept will be understood. There are some special situations of our nature where with increasing height in the atmosphere, I get increase of temperature instead of decline of temperature. Such special situations of atmosphere where instead of decline, instead of ELR, I get increase of temperature with increasing height would be called as inversion of temperature, and simply temperature inversion is okay. So when I get opposite of what I expected, then I call it as inversion of temperature or simply temperature inversion. Now write this sentence and then I'll make some clarification further. So please write temperature inversion refers to an atmospheric condition. Temperature inversion refers to an atmospheric condition in which with increase in height, put a comma, there is an increase in temperature, in which with increase in height, comma, there is an increase in temperature rather than the usual relationship, shown by the ELR, rather than the usual relationship shown by the ELR. Okay. Now, before we go further, let's have some clarification. With increase in height, when I get increase of temperature, instead of decline of temperature, I call it as temperature inversion. Okay. Now, I have given you one sentence for this temperature inversion, that it's a special situation where instead of decline, I have increase of temperature. And with that, I close my definition. But after the class is over, when you revise this lecture today or tomorrow, means I make an assumption that you will revise. Some student, and let's see how many of you will go on that line. Some students may assume that perhaps teacher wanted to make us write, but he didn't make us write, that this temperature inversion which he has given us relates to relates to stratosphere and to thermosphere. Perhaps teacher wanted to relate to these two, but he didn't mention us. He just gave us a definition because he kept saying that I'll do more later. So tell me, how many of you will have this interpretation? And be honest and raise your hands. Very good. Many students have raised the hands immediately. Some certainly would add furthermore. No, means some are not participating in the discussion by. But I know majority means many students, not majority, but many good number of students have raised the point. Now, in fact, one student is very honest online. Sanjay says, I was thinking of this only. Yes, we need such honest students. So those of you who are thinking like this or would think tomorrow when you revise the notes, my answer, my reaction is this would be wrong. Means I do not mean temperature inversion in relation to stratosphere or thermosphere. Now you will say, sir, why? Let's see. In stratosphere, we have ozone. Ozone absorbs certain ultraviolet radiations. So with increase in height, you expect what? Increase or decrease? You expect increase of temperature. You expect increase. You get increase. Would you have a reason to use the term inversion? Inversion in English language is used as a word when you get opposite of what you were expecting. Yes or no? So in stratosphere, because of ozone, you expect increase in temperature with increasing height. So you have no reason to use the word inversion. So I didn't say inversion for this particular zone. And that is why I didn't mention. Similarly, in thermosphere, because of ionization with increasing height, we expect increase in temperature. We expect increase, get increase. We have no reason to use the term inversion. So we didn't mean inversion for these two areas. This is clear. This is the best way to prove my point. Or some students should have understood this point with a common sense approach also. Remember, sometimes in the prelims, questions will be answered by common sense. By being in the examination hall, no? Now, what did I say in the beginning of the lecture today? They have not proved it so far. But I started my lecture by saying that very soon you'll get to have a very new, great, interesting learning that when a geographer uses the term atmosphere, he or she only means troposphere, unless until said otherwise. So it means right in the beginning of the lecture, I have declared without telling you much clearly that my lecture is only about troposphere. Yes or no? So anyone who is present mechanically also means with a commonsensical approach should understand that whatever he teaches today or tomorrow, it would primarily relate to troposphere. Yes or no? So that is another way to look at the things. So books do not write anything after that sentence, but for the reason of this kind of misunderstanding, write one more sentence. Please write, temperature inversion primarily relates to troposphere. So write, or just I change the word, please write, temperature inversion as a phenomenon. Temperature inversion as a phenomenon primarily relates to troposphere. Primarily relates to troposphere. Now, some student may say, sir, why are you not so confident that you say temperature inversion only relates to troposphere? Means some good student may be thinking that why he is writing after so much of clear point, that why he is making us write primarily. Why doesn't say with 100% confidence that temperature only relates to troposphere? Then I would say, number one, we are dealing with nature. So never ever I'll make an absolute statement. Today, even life is not absolute, no. What to think of nature? Nature is so complex. So remember, it goes without being said. I would have told you earlier also that every statement I speak in my classes of geography or ecology, like the other teacher, remember, nothing is absolute. Though we teachers will make it clear most of the time, but in general, you should also know that how can any statement be absolutely true for such a complex reality called nature? So this is one way to look at that. I'm using the word primarily because there may be some exception. Or let me tell you one particular point that in the coming days we'll be studying those special situations of our atmosphere which are giving us temperature inversion. Remember, today we are doing concept only. But as we go with the classes, we'll have to cover some special situations which are situations of temperature inversion. And questions have been asked in the prelims, and these applications would be important for mains answers also. So I have to teach you those special cases, and you'll find almost all the cases which I teach, except one, would pertain only to troposphere. But one case, and just one case, and unfortunately the one which I have to discuss today only, is the one which is an exception, which will take us little outside the tropopause also. Okay, so keep taking care of that point, that only today I have to discuss that case of temperature inversion, which is going little beyond the tropopause. So I make the word primary. Basically, I'm making it myself safe, that none of you can go for any kind of confrontation with me that, sir, you just wrote that it only relates to troposphere. So to keep the cases of some exceptional situation, I'm using the word primarily. So basically, whatever I teach, unless until otherwise stated, it would be primarily for troposphere. Okay, so this is what concludes this discussion. Now, no, where did you discuss? Means which stratosphere, which portion? One, I've already said I'll also go little into the stratosphere. Which case you have studied? Tell me, because anything in Hava you don't know. Means just to say that won't take us anywhere. Give me that case which you have studied so that I also get enlightened. Yes, dikha dena. Very good. I'm experienced enough, my dear. These are some smart students of the class who see a young teacher can go get swayed with you, but not with such an experience. Even if I go wrong somewhere, I'll have experience to manage my situation. And today I know I'm not really in a weak platform. I'm very strong platform, right? So, and remember, I'm such a student of nature today that I believe your knowledge is very limited. Means I understand, more you know, more you understand, your knowledge is less. Remember, what makes you wonder in life? Ignorance or knowledge? Knowledge. More you know, more you wonder about the kind of diversity we have in each. Remember, there's another quote of the day. नहीं, ऐसी कोई बात नहीं है. I'm a student. I'll never say teacher. तो my dear, मैं भी एक केस स्ट्रेटोस्फीयर में ले जाऊंगा अभी. वेट करो. When I have already said there is a cross tropopause, no? But what you say case in stratosphere, if you have any case which is not fitting in my presentation here, you bring that case, we'll discuss it in the class, right? The case which is going into stratosphere, I'm going to talk about that today itself. And that is why I made this statement primarily, okay? Now, with these all points, we are fully equipped to go back and analyze the diagram which we had given in the last lecture, and I started with the lecture that today. So please go back to troposphere with me and let's answer some basic questions. Don't go so far back in the pages, make a new diagram. Because you'll have to write many new things now. Make a new diagram fast. See, more you write, better it is for the UPSC examination. No? Don't use photostat notes and all that. Write more and more on the table. Sit on the table for long hours. Be alone in your life for next 1.5 years. And you will find first attempt is the only last, would become the last attempt. Now there's a student, Amit Maurya, asking me that, sir, why not in mesosphere? Because he says mesosphere is not discussed, no? So I've already given the answer in the second point. When I have already said, what is my real atmosphere? Troposphere. So it means I make it so clear that whatever phenomena we discuss in this class, they are primarily for troposphere. Okay. So my second observation was hinting at that mesosphere is also not included. Now let's have some basic observations and understand this troposphere. What is the first question in the mind? That why the height of tropopause is more over the lower latitudes as compared to high latitudes. Now, all what we have done till now would be useful for such questions answer. Be on the board and think of this. Can I say lower latitudes of the world are the most intensely heated areas? It means in the language of today's lecture and the last lecture's term, the lower latitudes have the strongest convectional currents. Convection, you know, current we have introduced today. So it means here the air is very warm, and warm air means going to rise, and rising warm air can be called as convection because there's a vertical transfer of it. Advection was the horizontal transfer, right? So lower latitudes of the world have strongest convection. Means here the air is very warm. And can I say warmer the air, higher it rises? And you learned today that as air rises, it gets adiabatically cooled. So it means this cooling, which is the defining feature of troposphere, would be seen up to higher elevations. But as I go towards the poles, convection gets weaker and weaker. The air would rise, but up to lower elevations. And cooling would be seen till the time air rises. By the time I reach to the polar region, the convection is further weakened and the rise of the air is only up to 8 to 10 kilometers, and cooling would be seen only up to that level. Now, you'll be surprised to know that since the air is rising to greater elevations, because here you have stronger convection, therefore cooling would be also more. And by the time we reach the tropopause over the equator, temperatures are seen generally around minus 80 degrees centigrade. But as I go towards the poles, since the convection is weaker, rise of the air is much less, so cooling would be also less. So yes, temperatures are low here, but the temperature is around minus 45 degrees centigrade. Remember, they may vary, but this is on an average, right? So minus 45 is warmer than minus 80. So does it appear to be some sort of a paradox? Means, does it appear to be something surprising that over the hottest areas of the world near the Earth's surface, we have up in the atmosphere colder conditions as compared to what is over the coldest areas of the world? But this is not a real paradox. This appears to be, this is an apparent paradox. What does it mean when I say this is not a real paradox? It's an apparent paradox, because class understands the reason for this minus 8, you know. That why do we have over the hottest areas colder conditions at the height of tropopause? Because here the rise of air is much more. Since it can be scientifically explained, so this is not a real paradox, it's an apparent paradox. So class understands the differential, or should I say the heights variation of the tropopause with the discussion I had done, that is in terms of heating of the Earth's surface. So let's write this one, then I'll take, and please add these values of minus 80 and minus 45. So please write. The lower latitudes are the most intensely heated areas of the world. The lower latitudes are the most intensely heated areas of the world. Put a comma. As a result, these areas have very strong convectional currents. These areas have very strong convectional currents. The right next sentence is the same point. Warmer the air, higher it rises. Next sentence, warmer the air, higher it rises. Next sentence, as it rises, it gets adiabatically cooled. Next sentence, as it rises, it gets adiabatically cooled. put a hyphen, right? Therefore, cooling is seen up to higher elevations. Cooling is seen up to higher elevations over the lower latitudes. Cooling is seen up to higher elevations over the lower latitudes. Full stop. Further, right, next point. As we go higher in latitudes, next point, please. As we go higher in latitudes, put a comma, convection gets weakened. Convection gets weakened. Put a hyphen. Warmer air rises to lower elevations. Warmer air rises to lower elevations. And hence cooling is seen up to lower elevations. And hence cooling is seen up to lower elevations. Cooling is seen up to lower elevations. Full stop. Further, right? This all explains the spatial variation in the height of tropopause from equator to the poles, within bracket as shown in the diagram. From equator to the poles, within bracket as shown in this diagram. Now, these are spatial variations, but I hope now you understand the other point also. Can I say, besides these spatial variations from place to place, can I say at a given place, the height of tropopause will vary from time to time? For example, can I say, summer is the time for stronger convection at any place of the earth? So it means in a place like Delhi or anywhere else in the world, the height of tropopause would be over that place. Higher means more elevation. In which season? Summer season. And it might have even fluctuations over daily basis as such, depending on the weather conditions. But today we'll see the picture broadly for seasons. As we mature with the classes, we'll have further understanding. So, right, next point. Besides the spatial variations, put a comma, the height of tropopause also varies. The height of tropopause also varies temporally. Means at a place from time to time. Also varies temporally at a given place. Put a hyphen and write. For example, summer is the time for stronger convection. For example, summer is the time for stronger convection. Summer is the time for stronger convection. And hence higher elevation. And hence higher elevation of tropopause at a given place. And hence higher elevation of tropopause at a given place. Now let's make a comment here. You have written these values minus 80 and minus whatever. So let's see that, let's write that it is not a real paradox. It just appears. So write one more sentence, one more point. Please write. It is apparently a paradox. It is apparently a paradox that the lowest temperature in the troposphere that the lowest temperature in the troposphere is vertically overhead at the equator rather than at the poles. At the equator rather than at the poles. Now, before I go to some additional point, I'll give you a factual information, though it will come in later other lecture, but just to not have a confusion, see here. I've told you that my primary focus is going to be only on troposphere. Means I'm going to prove it today that this is my real atmosphere. But sometimes we'll be studying other layers also of the atmosphere, other zones. So if the question is, where do we have the coldest conditions in the entire atmosphere? Then answer is at the height of mesopause. Means at the top of mesosphere we have generally the coldest conditions, and temperature may be around minus 90 degrees centigrade. So on the margin you write this. It will come later also in the lectures when we discuss mesosphere. So please write on the margin. The coldest conditions of the atmosphere are generally seen at mesopause. Put a hyphen, right? Temperatures around minus 90 degrees centigrade. Temperatures around minus 90 degrees centigrade. Let's come back to troposphere only. Now see, before I go further, let's have one common sense observation. In your books and as on my board, tropopause is represented by a line, but you must be mature enough to understand that in nature we'll never have abrupt divisions like this. Remember, tropopause is not going to be a rigid line like this. It is going to be more of a zone of transition. So remember one rule for all classes that will help you to understand nature. Nature never divides us. Nature always unites. Means whatever thing of nature you see, any phenomenon, you'll find nature always goes for integration. And in this context, whenever I discuss this, I give one more thought of the day. And this would be very good for essay writing. The earth is one, but the world is not. Did I give this earlier? Right? Means, did I give this earlier? No. So, the earth is one means nature is one, but the world is, the political map shows us that we have divided. So, every time we discuss nature, zones of transitions would be there. The man has gone for boundaries, no? The divisions, not the nature. Now, let us understand the main point of the day now, that what makes the troposphere our real atmosphere. Now, let's start with this simple discussion. If you ask me that, sir, why do we study atmosphere in geography? My simple answer, and you will accept that immediately, is that we study atmosphere in geography because we are interested in understanding weather conditions of the world. Am I right? Yes, please. So my primary reason for studying atmosphere is to understand the weather conditions of the entire world. Now, if you understand and agree with this particular definition, now we get a fact. Scientists of the world tell us that most of what you call weather, most of what comprises your weather remains confined in this zone only. So much so that we can call this zone as the real weather sphere of the nature. So if most of what comprises weather is in this zone, so don't think if my subject is weather only, so it means for my studies, which part of atmosphere is real atmosphere? It is troposphere. So I said most of what is comprising weather. Now I'll give you some practical examples so that you really get convinced. And then I'll give you a reason for it. For example, can I say clouds make one major constituent of what we understand as weather? Means clouds are one major part as well as very visible part and an important part of weather. So if you understand that clouds are very important element of our weather conditions, and now I say most of the clouds of the world remain confined within this troposphere. Remember, I'm using the words most always, no? It means nothing is absolute. It means some clouds will penetrate into stratosphere, but most of the clouds, most of the time, are within troposphere. And I'll give you a practical evidence of it for at least most of these, if not everyone, but most of the class. Almost everyone in the class would have gone by air. So in the coming part of the lecture today, you'll understand that when you fly, generally, your most of the time of the flight is spent here, just above the tropopause in the lowest part of the stratosphere. It means the first thing a pilot does almost world over is that having taken off from a city, he or she takes or puts the machine in ascending mode. And depending on which area of the world you are flying, he or she takes it above the tropopause. And once here, the machine is put in auto mode. And these days, technologies are so good, and here the conditions are generally so good that pilots have nothing to do much after this. Means most of the time of the flight is spent here only. And that is why you see the belt sign, for example, goes off after a few minutes once you reach here. And for most of the journey, you're not asked to wear means they say you are supposed to wear, but they don't compel you. And this is the time when they serve you with snacks also, because now there is not much of turbulence, etc. So this is the ideal zone for flying aircrafts. Exceptions will always happen. Now we'll discuss this point a little later in detail, but I want you to recall your experience. When you are flying at this height, when you peep outside the window, you find that there is all very visible, clear. Means there's a great visibility all around. Only at distant places you have some clouds, some patches of clouds. But the moment you see beneath the aircraft, since you are flying above the tropopause, it means you are flying above the clouds, so you are not able to see much because everywhere you have clouds only. So it means this proves with your practical evidence that once you go beyond the tropopause, you have very less clouds left. So my point is proved that most of the clouds are confined generally within troposphere. And not only clouds, other elements of weather also. So this was just a practical evidence for most of you. So it means scientists say that this troposphere is like a container which contains most of what we call as weather. And the tropopause acts as the lid of that container. And this lid generally doesn't allow the clouds and other elements of the weather to penetrate into stratosphere. Some clouds will, some elements will, but most of the elements of weather will remain beneath. Means it's a good lid. It is effective. But yes, at places, it may not be very effective. At times, it may not be. But in general, it is keeping most of the things of the weather within the troposphere. Then what is the next question in mind? Next question would be, what makes the tropopause as the lid of the troposphere? Why the weather elements do not go into stratosphere? Then answer comes from the previous part of the lecture. And this would be our first example of temperature inversion. See here. Let us check what happens now in this troposphere and above the tropopause. Air near the surface will get warmed everywhere. You know, Earth is getting heated with the sun, and this solid Earth is acting as a good radiator. So because of out radiation, air near the Earth's surface in the lower troposphere gets warmed, and warm air rises. It means almost everywhere in the world we have convectional currents, somewhere stronger, somewhere weaker. And as this warm air rises, we learned today, this air gets adiabatically cooled. How much cooled? Over the equator, as much as minus 80, and over the North Pole or South Pole minus 45. In between, you can think of minus 60, minus 65, minus 58, and all that. Those who have been in international flights would have seen that during your journey, they give you temperature conditions outside. So depending on which area of the world you are flying in, you will have some value between these two extremes. So just beneath the tropopause, conditions are very cold. But in stratosphere, you have learnt we have ozone, and we'll get the specific details in the discussion on stratosphere later. But you know today, since stratosphere has ozone, so here the conditions are warm. Now, if you move from this place X to this place Y, can I say it is going to be an increase in temperature with increasing height? So this is an exceptional case of temperature inversion. Why do I say exceptional? Because mostly we'll discuss temperature inversion within troposphere. So now, is everyone clear that there occurs a case of temperature inversion across tropopause? Yes, please. So I make a statement. Tropopause acts as the lid of the troposphere and generally doesn't allow the elements of weather like clouds, etc., to penetrate into the stratosphere because there occurs a case of temperature inversion across it. Now, are you able to understand the reason? Those who are not getting it, see here. My right hand represents the colder conditions beneath the tropopause, and my left hand represents the warmer conditions of the stratosphere. So remember the rule always. And I told you that we have golden rules done today. Which air rises? Warmer air. So remember, whenever in the atmosphere we have colder conditions beneath the warmer conditions, this air, this condition cannot go up. It has nothing but the only option to come back. Yes, please. So because of temperature inversion, means because of colder conditions lying beneath the warmer conditions, this becomes the lid of the entire troposphere. Now, let us answer this one more question in addition, that why do scientists, or why did scientists name troposphere as troposphere? So see here, warm air gets warm near the surface, it rises, gets cooled. This air cannot go up. This air would somewhere sink back. And as air sinks back, it gets adiabatically warmed. And Earth's out radiation would warm it further, and it will again rise. So it means what is happening all the time in troposphere? Air gets warmed, rises, gets cooled, comes back. Again gets warmed, again comes back. So it means it becomes a zone of the atmosphere in which air keeps turning itself. So the word troposphere comes from the Latin word tropos. And tropos means a turn. So it means it is that zone of the atmosphere in which air keeps turning itself. Okay. So let's write this much, then I'll take you further. Please write. Most of what comprises weather remains confined within the troposphere. Remains confined within the troposphere. Put a hyphen, right? Troposphere is a real weather sphere of nature. Put a hyphen, right? Troposphere is a real weather sphere of nature. Please write for the next point. Tropopause acts as the lid. When you write the word lid, write within inverted commas, because generally this word is not used here. So please write, the tropopause acts as the lid of the troposphere And generally it does not allow, the penetration of please write the way I am writing on the board, weather elements within bracket like clouds after this, right, into the stratosphere, and generally doesn't allow the penetration of weather elements within bracket like clouds into the stratosphere. Full stop. Further right. Tropopause acts as a lid. Tropopause acts as a lid as there occurs temperature inversion, across it. There occurs temperature inversion across it, put a hyphen, that is colder conditions lie beneath the warmer conditions. Next point now. Please write, air gets warmed near the earth surface. Air gets warmed near the earth surface. The right. Warm air rises, next sentence, warm air rises and gets adiabatically cooled. But as this cold air cannot go beyond tropopause, put a comma, it sinks back. Put a hyphen, right? Troposphere becomes the zone of the atmosphere. In which air keeps, yes, please complete the sentence. Air keeps turning itself. In which the air keeps turning itself. And within bracket, right? Tropose in Latin means a turn. Okay. वार्म एयर कहाँ जाती है? ऊपर जाती है अंश. ठीक है. Yes. We learned that's why I said you have golden rules of the subject. No, two simple rules will work wonders in this subject. Now let's go back to our general discussions. We'll come back to this diagram, but let's learn one more concept of atmospheric science. See here. With increase in height, this is what I call as 80% effort in life. And it's a waste of time, I tell you. Those who make 80% effort in India, they reach nowhere in life. Sorry to say this. Whether it's examination, this exam, or anywhere else. In a country like India, unfortunately, you need to go for 120%. Realize this and you will understand the point. That we Indians need 20% extra. Because see, we're number one in population. So everywhere there's a crowd. So reach to success or reach to a particular position, you need to make more efforts. Remember, when you go extra mile, there is very less competition. I hope you means extra mile, you have no traffic congestion also. Means you have less competition life. So if you are here in this examination, go to little extreme. Then only you'll find that first attempt was the only attempt required. Now, I'm not saying that you are not supposed to go out if you have any problem, no. But learn to sit for 2.5 hours. If the teacher can do it, I'm elder to you, I told you by 5-6 years. Still, I'm managing the show. This is my third lecture of the day, right? But I'll not show any kind of lack of energy till the lecture is over. When I reach home, then I'll tell the people at home, it was a very tough day. No, so that they don't do anything, means they give me all services. Means inside I may not be tired, but I'll make them feel that I've done a great job today. And it's almost every day. So rule at home is that I tell my wife, don't fight me when I'm going for the class. Did I tell you earlier? Yes. So point is that please have energy level in the class. That is, those who remember, those who go out, just check, be a scientist in the class always. Make observations around you. You'll find these are regular faces. And some are such regular, some students show such regularity that at appointed time interval, they will leave the room. You teacher says very important point comes on the board and he or she goes out. So next time you will find you go out, I complete the main important point. Okay. So like be on the board now. Let's learn something new now. So please attempt making 120% effort. No. 80% effort is no effort in life. If you realize fast, you perhaps would understand. You will not waste your time in Delhi. With increase in height, generally we expect, I expect and generally we get decrease of temperature, right? Means rule is this. But exceptions have been seen that there is, with increase in height, increase of temperature instead of decrease. One example we have seen, but more examples will come. I'll be discussing 6-7 examples of temperature inversions in the class. Now, Mother Nature is far more complex. So the third possibility is this, that I go up in height and for a few kilometers, say 5-6 kilometers, I find there is almost a constancy of temperature. Neither there is any significant decline of temperature. Mind the words carefully. Neither there is any significant decline of temperature and nor there is a significant increase of temperature for few kilometers, say 4-5 kilometers. Such a zone in which there is almost a constancy of temperature with increase in height in the atmosphere. Remember, everything is being discussed in vertical frame. So this zone, where for a few kilometers we have almost a constancy of temperature with height, is called as isothermal condition. Please don't write, follow me on the board. It is called isothermal condition. Thermal for temperature, iso means same. Now, if I give this, means if you have understood this point, it's a situation where if I go up for a few kilometers, there is neither a significant decline of temperature nor a significant increase. It means minor changes may happen, but I'm not getting those changes which I normally get. So then I call it as a condition as isothermal condition. A good student of the class will ask me, sir, where and when we get such a situation? Give us an example. My first reaction would be that such a situation may happen anywhere, anytime. Because you know what is atmosphere? Can I say it is every moment it is changing outside? Means if I just make it a broader approach and I take you to CSAT classes, you know, our atmosphere has n number of elements. And you have done something called permutation combination. So can I say every moment outside, Mother Nature gives us a different state of the atmosphere with a new permutation combination of these n elements? So who knows, in a particular area of the world, in a particular part of the atmosphere, I may have such a combination where for a few kilometers I have almost a constancy. But in the next permutation combination, this may not remain there. It means these may be more of transitional situations. And since we are in a GS class, we are not interested in such kind of changing conditions. Who is interested in this? Scientists are interested. Civil aviation industry is interested to have better technologies for the aeroplanes and all that. People in weather department may be interested. But we are in GS class. So a good student may ask me, sir, is there any zone of the atmosphere in which we have more or less a permanent kind of isothermal condition? Then I'll say, yes, we have one zone in which we have almost a sort of permanent, more or less permanent isothermal condition. And which is that zone? Let me just remove this. What is that zone? It is this zone, the lower part of the stratosphere, just above the tropopause. So what you do is mark a few kilometers, 4 or 5 kilometers here, and mark here isothermal zone. So the lower part of the stratosphere, just above the tropopause, is generally having isothermal conditions. Now, what is the first question now in your mind? Yes, please. Okay, I'll raise the question also myself, right? You don't worry. You stay relaxed, right? You just be a listener. Now, the next question, as per my preparation, is that why is it so isothermal? Why it is isothermal? What makes it isothermal zone? Now, to answer this question, I basically need to answer two questions. That with increase in height in this zone, why there is no significant decline of temperature? And I also need to convince my class that in this zone, with increase in height, why there is no significant increase in temperature. So one by one, I'll give you the reason, and this will be proved that it's an isothermal zone. Now see, what is the reason for decline of temperature in our lecture today? Can I say reason for decline of temperature with height is the rising air, convection? Yes, please. And you have just been told that convection normally stops beneath tropopause. It means in stratosphere's lower portion, either we have no convection or we have, if any, very weak convection. So since there is no rising air here, so that tells us the absence of, or that proves the absence of declining temperature with increase in height. So it means the absence of strong convection in the lower portion of the stratosphere would give us the understanding that the temperature would not have any significant decline. Now, what is the reason for increase in temperature in stratosphere? Ozone. So ozone is the reason for increasing temperature of the stratosphere. Now you please recall your school day science, and you'll know that ozone is not uniformly distributed in the stratosphere. Most of the ozone will start after 25-26 kilometers from the Earth's surface. So it means in the lower part of the stratosphere, we do not have much ozone for temperature to have any significant increase. So one, we do not have much ozone, and second, we do not have any much stronger convection here. So for this reason, it becomes a isothermal zone. So please write a note on this. So write the title isothermal zone. So topic is isothermal zone. Please write. It is a zone in the atmosphere. It is a zone in the atmosphere in which, with increase in height, there is almost a constancy of temperature. In which, with increase in height, there is almost a constancy of temperature. put a hyphen, that is, there's neither a significant decline, there's neither a significant decline nor a significant increase of temperature. There's neither a significant decline nor a significant increase in temperature. Then write further next point. In this zone, just cut this. Now you write the lower part of the stratosphere. Next point, please. The lower part of the stratosphere, just above the tropopause, the lower part of the stratosphere, just above the tropopause, put a comma, in general, again a comma, in general, represents isothermal conditions. I repeat, the lower part of the stratosphere, just above the tropopause, comma, in general, comma, represents isothermal conditions. Full stop. Further write in the same point. In this zone, comma, with increase in height, comma, temperature does not increase much. Temperature does not increase much as, please complete the sentence, as there is not much ozone here. That there is not much ozone here. So I repeat, you have written in this zone, comma, with increase in height, comma, the temperature does not increase much as there is not much ozone here. Similarly, write one more sentence. In this zone, again same way, in this zone, comma, with increase in height, comma, temperature does not decrease much. In this zone, comma, with increase in height, comma, temperature does not decrease much as there is not much convection here. As there is not much convection here. So is that okay? You have understood isothermal situation and you have understood there is one particular area where there is more or less a permanent such situation. Now we'll see that this becomes the ideal zone for flying aircrafts. With more of classes, we'll have more details, but today we'll have at least a broader picture. And there was a question long back in UPSC for this particular portion, that what makes this zone, the lower part of the stratosphere, ideal for flying aircrafts. So today we'll have three answers, three reasons for it in a broader way, and details of it would be understood much better as course goes further. So please write in the same next point. This isothermal zone provides ideal flying conditions for flying aircrafts because of the following three major reasons. Now, before I give you the reasons, please see here. So as I told you that practically that whenever you miss in most of, remember some flights, it may not be there. In most of the flights you take, the pilot having taken off from the city would take the machine in ascending mode and will take it there at the height above the tropopause, depending on the location where you are flying. And that is why in this journey, your belt sign is always on, right? Because you are passing through the atmosphere, so there could be turbulence and all that. But once here, the belt sign goes off and machine is put in auto mode. And then I said technologies are so good these days and conditions here are so good that pilots have almost nothing to do. Means the plane takes care of itself. And it is so free a zone for the pilot that now they get engaged in other things of life. Means they read, again misunderstanding. They may read a book, right? Or they may come to talk to passengers outside sometimes. Or they may even sleep. Though they are not supposed to, but there has been a practice among the pilots that they do sleep. And generally what they do is, at one time, one will sleep. But sometimes it has been found both slept. And in 3 or 4 cases, which I remember in last 20 years or so, both the pilots slept and the plane went beyond the destination. There was one such case in Mumbai 4 or 5 or 6 years back, that for 40 minutes or so, plane went beyond the destination and then they woke up later. And then the plane was taken back and certainly investigations were to be done. And it was found that both were sleeping. So if the question comes in UPSC, which is that zone of the atmosphere in which pilots might be found sleeping, it would be this zone. But since the UPSC cannot ask such a question, no? So they will ask better way that why this zone is ideal for flying aircraft. So we'll have broad answers. Details will automatically get understood as the subject goes on. Number 1, what is the reason? Now see here, for civil aviation, for flying aircrafts, you need more visibility. Yes, please. It means more visibility would need less of clouds or absence of clouds. So this area is the best because here you have more visibility. So absence of clouds, so more visibility. But remember, as the lectures go further, you will understand sometimes a cloud can be a safety concern also. But today you will not understand all that because sometimes there will be so much moisture in the air and conditions may be so placed that the moisture may immediately freeze over a metal body. Have you not seen the pictures in temperate areas of the world or Himalayas, for example, where on the branches of trees or other, say, power transmission lines, the moisture gets frozen. So imagine a plane is going through a rich cloud in terms of moisture and lot of moisture gets frozen on the body of the aeroplane. That could be a big safety concern. Or you also know that we have lightning in the clouds. So basically, in general for visibility and in particular for these kind of safety concerns, we should avoid clouds to the extent possible. And the best zone for avoiding clouds for most of the time of the journey is that go above the cloud side, that is tropopause. So right, first point, will not go into detail because this will all get visibly manifested later. So please write number 1, in general, the absence of clouds. It means some clouds might be there. So in general, we are saying, so first good thing is, in general, an absence of clouds. Now, what is second reason, which is good for this, why we go for preferring this zone? The very nature of this zone, it is, yes please, isothermal, means for a few 5-6 kilometers here, temperature doesn't change much. In the coming days, you'll understand if temperature doesn't change much, the pressure conditions will also not change much. It means the kinds of problems you have, turbulence, etc., and other things which you'll get to know, they would be less here. So the isothermal conditions would be the conditions which make the journey more smooth, means less of problems. So right, in general, the isothermal conditions, in general, the presence of isothermal conditions. In general, the presence of isothermal conditions. Now, the third point, last point, see here. If you were to fly your aeroplane in the troposphere somewhere here, don't think all the time the aeroplane will get disturbed by the rising air currents. Sometimes they can be very strong also. So in general, there would be a disturbance, or in sometimes it may be a safety concern. So plane needs to avoid the convection currents, and the best is that you take it to the height above the tropopause because there we generally don't see much strong convection. So please write the third point is, in general, absence of strong convectional currents. In general, absence of strong convectional currents. Now, this is the first round of our lecture on atmospheric science, where I have given you the basics of troposphere. Now we need to prepare for the larger issues of this atmospheric circulation. So what I do now is that I go for a few observations as per the time. I'll take up the topic so that we can complete it. Now what I do is I'll give you one particular design in terms of air circulation, which will link us, or which will give us a linkage between lower troposphere and upper troposphere. Okay. Now, can I say, or I don't say, please, what you do is write the title first. Zones of convergence or divergence of air. Now, I'll not make any observation, but see, a student is making a very wrong statement online. Now, since I said that aeroplane means we have near the tropopause, the ideal flying zone. So someone is writing, just lift it up. So someone is writing, I'll not name the student, that it means if you were to fly near equator, we'll have to travel more height, and near Britain it will have to travel less. See, that is already means, what did I say in the whole discussion? That you have to fly above the tropopause. So depending on the location, I kept saying throughout the lecture that depending on the location, the plane will be taken above the tropopause. Is it clear or not? So I don't know why comparison is being done with Britain and all that. If it is only about height, then it's fine. That I have already mentioned. I don't know what exactly means. I wanted to comment on it, but I'm not going further. So is that okay? That at what height the aeroplane would be taken would depend on location. Okay, I'll not go further because anyway, leave it. Now the topic is zones of convergence or divergence of air. And please don't write and follow me on the board. I said because of differential heating and Earth's rotation, we have zones of low and high pressure. And you know, air moves from higher pressure to lower pressure. I said wind is nature's attempt for balancing the unevenness of pressure. So every moment air in nature outside, we have the low and high pressure conditions getting formed, and nature is attempting balancing act, and that is the reason that air is in a hurry. But you also get to know that there are certain low pressure conditions and high pressure conditions which maintain themselves. Remember, if my area has lower pressure and outside you have higher pressure, what is going to happen generally outside in the nature? Air would rush from the higher pressure to low pressure. And as this area gets filled up with more air, this area would not have any more low pressure conditions. So what is normally happening in nature? Low and high pressure conditions form and they vanish with the movement of air from higher to lower pressure. Is okay for everyone? So I repeat my point. What is happening in nature all the time? Pressure differences take place, occur, and nature keeps balancing this unevenness by making the movement of air, what we call as wind. This is one part of the story. But then you also get to know that in our nature, low pressure conditions and high pressure conditions may maintain for some considerable time duration. Think of this point, that one picture of the nature is low and high pressure conditions form and they vanish because nature is always attempting the balancing act. But besides this picture, we also have another part of the story where low and high pressure conditions sustain for a good time period. Now, to convince you on this point, I'll have to go for some extreme example today. But it's just for an example, otherwise it's not the topic today, we are not mature. Think of a term like cyclone and the antithesis of it as anticyclone. Now, today you are not mature enough to understand exactly what are the technical details of a cyclone or anticyclone, but today I'll say cyclone is a wind system with low pressure the center. Means a wind system where pressure the center is low and outside you have high pressure. And anticyclone is an antithesis of it. It means a wind system where pressure the center is high and outside you have low. Okay. Now, you might not have heard of anticyclones, but you have heard of cyclones in news. And when I'll teach you the cyclone topic, we'll say, geographically speaking, there are two types of cyclones. The ones which occur in tropical areas would be called as tropical cyclones, and the ones which are outside would be either called as extratropical cyclone or they would be called as temperate cyclones. Now, we as an Indian, you have seen more of tropical cyclone. So please recall from the newspaper reading or TV channel news that a particular tropical cyclone which was in news, it remained in news for how many days? Roughly 32 to 34 days. Hours, okay, I thought. He says 32 to 34 hours. Anyone else? You said days. Freddy, only one Freddy. Means you read about Freddy only in life. Very good. Means I was surprised. And that's why days. There was a cyclone just 1 month back, Freddy, which has crossed all limits. But since we had, remember that it was an exception, so we'll talk about general things only. Right? So let's ignore his, he knows more than what I need. we need to be normal general behavior first. Anyone else? How many days? Yes? He says 5 days. Very good. I'll say this as a good answer. We generally say for a week or so. Means a tropical cyclone generally has a lifespan of about 1 week. It remains in news for 6-7 days. Now, you have not heard of anticyclones in news because in news we have bad elements only. Good elements are not generally in news. So you will see cyclone is in news because cyclone is an indicator of bad weather conditions. Anticyclone is an indicator of fair weather conditions, and generally it is not in news. But you do remember, sometimes good people are also in news for wrong reasons. Right? Means you expected is good, but inside he was not good. So sometimes anticyclones are also news. But you have not heard of them so often. But I'll tell you that a fully developed anticyclone may persist in nature for 2 to 3 weeks. So let us think of this. Let's think of it and see what is the picture which we'll get out of this discussion. See here. Let's say it's a low pressure area. Now, you know, air will rush into this low pressure. Yes, please. So air will come from all possible directions into this low pressure. It means now let's first handle the title. What was the title I wrote? Zone of convergence of air. So can I say a zone of convergence of air would be a zone where there's a net inflow of air? And can I say low pressure conditions make zones of convergence? What is zone of divergence of air? A zone from where air diverges out. So it means if I take a high pressure system, what is going to happen from high pressure? Air would diverge out in all possible directions. So what you do is first write the definition of zone of convergence and divergence. Bharti Yadav had given the right answer here 1 week. I didn't see online. No, I should see like this also. Means she gave the best answer here. Anyway, now right. A zone of convergence of air is a zone. A zone of convergence of air is a zone where there's a net inflow of air. Where there's a net inflow of air. And in the same sentence, you write next point, means in the same point, next sentence, low pressure conditions make zones of convergence. Yes, would you agree with this statement? Low pressure conditions would make zones of convergence. I repeat, a zone of convergence of air is a zone where there is a net inflow of air. And second sentence you written, low pressure conditions result in zones of convergence. Now write the opposite. A zone of divergence of air is a zone. A zone of divergence of air is a zone where there is a net outflow of air. Where there is a net outflow of air. And right next sentence, high pressure conditions result in zones of divergence. High pressure conditions result in zones of divergence. So please be on the board. So what is happening very often in nature? Low and high pressure conditions form and air rushes in from high to low pressure, and these conditions keep vanishing, keep disappearing. But then I give you an idea today that we have some, now mind this point, we have some low pressure conditions and some high pressure conditions which sustain in nature for a significant time period. Now, there could be many examples of such low and high pressure conditions. But since you are only aware about cyclones and anticyclones, so I gave that extreme example. So, you know, cyclone is, you can write definition of cyclone, anticyclone on the margin, because this is not the topic of the day. So, write on the margin, a cyclone is a wind system with a low pressure the center. A cyclone is a wind system with a low pressure the center. And write second sentence, anticyclone. An anticyclone is a wind system with a high pressure the center. An anticyclone is a wind system with a high pressure the center. Now, I'm taking these extreme examples only because you read about at least cyclones in the newspaper, no? So, imagine, what does it mean when you are told that a cyclone persists in nature for about a week in tropical areas? And in fact, this was a surprising point this time, that we had a cyclone by the name Freddy, which has gone for existing about 1 month or so. The scientific agencies of the world are still having a research on the work to decide why and how did it happen and other details as such. But generally, lifespan of a tropical cyclone is 1 week. Now, we wish to raise a question that if cyclone or any low pressure system, remember cyclone is just as an example because you know about it, but think of a general point. If there is a low pressure and air is converging from all possible direction, how would Mother Nature ensure it remains a low pressure for some significant time period? Because normal understanding tells me that this area is low pressure, air converges here, and this area should not be anymore. Yes, please, low pressure. But now we know that in nature, low and high pressure conditions persist for days together. So what nature would ensure? Nature would have to ensure that this air which is converging, so the air which is converging from all possible directions, it should not be allowed to fill up this area. Because if this air fills up this area, it won't remain anymore low pressure. So what the nature will do is, nature will create some arrangement in the upper troposphere. And this air, before it reaches this area, it would be taken up. It means if a system of convergence has to sustain, there must be upliftment of air. And you already have understood, as the air would rise, it will get adiabatically cooled. And finally, there comes a height beyond which it cannot go up. So it means at some distance, it has to diverge in the upper troposphere because it can't go up. So it would diverge. So look at the design. Can I make a rule now? for every zone of convergence in the lower troposphere near the Earth's surface, there must be or there is always a zone of divergence in the upper troposphere. So we get a design of air circulation for the coming classes. Is this understood? Now some student will tell me after the class, sir, what if air doesn't go up? And then I say, low pressure doesn't sustain. Means what is happening more often in the nature? For example, tell me, do we have cyclones every day? No. So it means what is happening every day is air doesn't rise. Story gets over there only. But if nature wants to maintain it here as a low pressure, there must be some arrangement of this sort. It means air which is converging in my area, nature must create a suction here so that this air, before it fills up this space, is taken up. So there is a convergence near the Earth's surface in the lower troposphere, and there is a zone of divergence. So please make this diagram and first write a sentence, then make this diagram. So please write, for a zone of convergence near the Earth's surface, means lower troposphere. For a zone of convergence near the Earth's surface, put a comma, there is a zone of divergence in the upper troposphere. There is a zone of divergence in the upper troposphere. Please make this rough sketch. And remember what is like, okay, just one minute. Okay, first make the diagram. If you recall school teachers understanding here, school teacher used to say, a cyclone is an indicator of bad weather. Because what is going to happen with rising air? This air will get cooled, and I give you a hint, cooling will make clouds. Clouds will give you heavy precipitation. Because in a tropical cyclone, this low would be very low. There will be a strong movement of air here. You'll be surprised. You know, tropical cyclones are very destructive in nature. You'll be surprised to know later that minimum wind speed in this system is 119 kilometers per hour. Minimum. And in reality, most of the cyclones will have double, triple of that speed. But all those things, you are not mature today. We have to discuss many other things. But this design is to be understood. So there is a zone of convergence, there is a zone of divergence. It's an indicator of bad weather because clouds will happen and then you'll have precipitation, etc. Now I'll come back to this for some further observation. Let's see the opposite now. A high pressure zone means a case of anticyclone. And I said anticyclones are generally sluggish. They persist for much more time. Now, so imagine my area is high pressure zone. Air is diverging out in all possible directions. Normally, what is expected? That after a few minutes, this area would not be any more high pressure. But then we have some special cases where high pressure conditions sustain for days together. If it's a fully developed anticyclone, it may sustain for 3 weeks. So it means nature has to ensure something more. So it is something like a rich family spending a lot. But you know, rich families remain rich despite great expenditures. How do rich families remain rich despite all expenditures? Because they have constant earnings also. So this area is losing its losing its air in all directions. But nature wants to maintain it still as a high pressure. So nature will ensure the supply of air from the upper troposphere. It means as more and more of air is diverging out, there's more and more of supply. It's like family spending a lot, but there's constant earnings which keeps it. Means rich families have a surplus at home all the time. Means what kind of challenges the family has at the dining table? The head of the family says, go and spend tomorrow. Means is getting rid of the family members, don't disturb my peace. Go and spend. He knows that they can't spend what I earn. So he says, go and spend, and when you come back, you'll find there's a surplus of wealth at home. Because he knows my earnings are great. So this is what anticyclone is. So it means for this to happen, Mother Nature will ensure the zone of convergence here. And here there would be divergence. So write the opposite statement and then make this diagram. For a zone of divergence, this is low pressure only. Just wait, I'll make it clear. Just very good. So please write the opposite statement. For a zone of divergence near the Earth's surface, For a zone of divergence near the earth surface, put a comma, there is a zone of convergence in the upper troposphere. There's a zone of convergence in the upper troposphere. Please make this rough diagram. Now, why school teacher said an anticyclone is an indicator of fair weather? Because what is expected, air is going to sink here, will get automatically warmed. And in the coming days, you'll understand any air which is getting warmed will not give you clouds. So this area would have clear skies, dry conditions. So it is a fair weather condition. But school teacher was not that, he was talking simple things only. And in the higher level classes like our class today, means in the coming days, you'll find sometimes anticyclones can become a nuisance for people in one area. So later you'll understand if this system develops in a city like Delhi, it would be a problem. Because later you'll understand, since Delhi is highly polluted, the pollutants which are there in the air near the earth's surface, normally what happens is when the sun would hit the earth, the air near the earth's surface get warmed, and warm air will take the pollutants away, and that pollution will get diluted further as this pollutant would mix with the other gases of the atmosphere in the higher elevations. So people in Delhi get a relief by nature with the rising air. But imagine you have pollution in air near the earth's surface and this system develops. Don't you think pollutants would remain near the earth's surface, and that too for 2 or 3 weeks? It means hospitals like Gangara would have long queues because people who have breathing issues, they would have tough times in this period. So that is the time anticyclone would be in newspaper because it's a nuisance for the people, right? Now, these are the things will be understood as we go further. Now, he said there is a low pressure. Yes, these are all pressure conditions. Remember, what is this zone of convergence? It's low pressure. This is high pressure. Here, high pressure. This is low pressure. But now comes the most important point of the lecture. Means how do you close the lecture? Don't do it with any teacher. I'll close the lecture. This one most important point still to come. The way I have explained the things, it might sound to many of you that perhaps the teacher is saying, for this to happen, the cause lies in upper troposphere. And for this to happen, cause lies in the upper troposphere. Tell me, did you get this feel? Yes, many of you would have got this feel because I sounded like this. But I make a clarification. That even if I have sounded as if this to happen, the cause lies in the upper troposphere, and the same here, I make it clear that scientists do not know that which out of the two is the cause and which is the effect. Now you will say, sir, why did you sound like that? Because we human beings are on the earth's surface. We'll first investigate what is happening near the surface. When our scientists will find, when our scientific agencies, weather department will find that in Bay of Bengal, a low pressure system is developing, means a cyclonic system is emerging, then they will check what is the situation, the upper troposphere. So their starting point is normally the earth's surface. That is why I also started here, because we are on the earth's surface. But the end of the story is that both of these are correlated with each other. Means now I'll say we do not know exactly which is cause and effect. But we have never seen a cyclonic system in the lower troposphere without an anticyclonic system in the upper troposphere and vice versa. So remember, in almost all the complex parts of atmospheric science, our discussions will not reach to the level of cause and effect. Our studies would be based on correlations. Remember, when you have too many parameters or too many variables which make a phenomenon, don't you think cause and effect might be not visible? For example, can you have correct and clear causality relationships in the success and failure of this examination? Don't think you can at the end say, I failed because of so many reasons. No, means you can't blame our classes alone. Means it's a guarantee that you can't blame our classes. And the same way, we can't claim that your rank is only because of these classes. No. So your success or failure in this exam would be the combined effect of many things together. So since basically you have to understand today that we are in a subject called atmospheric science where there are too many variables. And those variables are integrated in a very complex way. So most of the studies would be based on correlations and less on cause and effect. For example, Indian monsoon, you know from newspaper, relates to some event called El Nino in the Pacific Ocean. And that is just one factor. And that El Nino relates to many other things of the nature in different parts of the world. So in such a subject, where the whole atmosphere of the world is acting as one integrated atmosphere, and later you'll understand as the classes go further, that not only atmosphere is acting as one integrated whole, it is acting in conjunction with the ocean of the world. So both are partners, and the results are complex with teleconnections. Teleconnections, you understand, connections between far-off events. And those events, not only which are far off in terms of distance, the ones which are also separated by time together. Means one event takes place in one season and it is found to be related with an event in the next season in another area of the world, which is thousands of kilometers away. So in such a subject, we have to remember this is more of correlation, not cause and effect. It's something like I found as a student when you are studying here that you found one student came to the class and immediately the second student also comes to the class and both sit together. And you happen to see this by chance. And next time you become a scientist, you start observing this reality. And you found for next 15 days, both came together almost the same time. Both sat together. One left the class, the other also left the class. So you noted this for 2 weeks. And the other day you were having a cup of tea at the tea stall and you found there are 3 other scientists in the class doing the same study. And you out of curiosity ask, what are your results? And they show these spreadsheets that they also show the high correlations of the times of arrival and times of departure. Don't think 4 scientific studies showing high correlation means you have a reason to suspect. I hope you understand the point. This is now, don't misunderstand my approach. This is the way we'll study atmospheric science. Means those who think of writing cause and effect answers, they will not get that scope in this exam or in this particular area, because and it is not only atmospheric science. Don't you think the same way medical science has complexities? That you can't reach cause and effect. That is why most of the treatments doctors do on the basis of symptoms of the body. So wherever complexities are there, we'll have more of correlations and less of cause and effect. So please write the point on the last point of the day. The lower and upper tropospheric conditions, are found to be correlated. Put a hyphen, right? In atmospheric science, we may not always have the possibility of causal explanations. We may not always have the possibility of causal explanations. Now, there's a very good comment on the online. Sanjay is writing that this is why perhaps IMD talks about low pressure zones when there is a chance of cyclones and all that. Yes, you will find first the scientific agency will find there's a low pressure system getting formed and there would be a term called depression for a weak low pressures. Listen to me. A low pressure system would be formed which is called depression, and scientific agencies will say perhaps there are chances that this depression may intensify into a tropical cyclone. Okay, so these kind of things will come in the classes. Now we stop here. I'll take leave from online students. Keep smiling, stay blessed, enjoy the process. Thank you.